We've nearly survived Chapter 3, Stoichiometry. Here's the last problem in this unit. If you feel relatively comfortable with these percent yield calculations, you could skip this one altogether. It's very similar to the last one. If you need a little bit more review, you want to walk through one more, then this is for you. We have an equation. We're going to react some sodium oxide and carbon monoxide to produce sodium carbonate and sodium metal. That sounds fun. In the lab, we have 50 grams of sodium oxide, 19.2 grams of carbon monoxide, and 17.8 grams of sodium metal actually collected. That's nice. They use the word actually. That's our actual yield. So we just need to calculate the theoretical yield. And initially, that's going to look like a stoichiometry limiting reactant problem. So we've got the amount of each reactant, 50.0 grams of the sodium oxide, and 19.2 grams of carbon monoxide. So we want to get these out of grams into moles. Put them into moles. Let's see here. Sodium, 2 sodiums, and 1 oxygen. 61.98. Cancel grams. Put this in moles. Carbon monoxide, 28.01. We'll leave 3 sig figs for each. So this should be about 0.806 moles of sodium oxide. Ooh, 0.686 moles of carbon monoxide. Okay, so here's the amounts that I have. Sometimes I still just write that in, so I just kind of remember. This isn't a crazy ratio. I can use the ratio from the balanced equation as a 2 to 1. I'm supposed to have more sodium oxide. I'm supposed to have twice as much. So if I look at these quantities, I'm supposed to be able to multiply this by 2 and figure out the amount of sodium oxide I would need. However, I think this one is easy enough to do in my head. I don't have anywhere near twice the amount of sodium oxide. Yes, I have more, but not twice as much. I mean, just by estimation, I can tell you that. So without a doubt, this is my limiting reactant, the sodium oxide. The carbon monoxide must be in excess. So again, now they might ask you, justify your answer. You could justify your answer with a sentence, an explanation. Well, I looked at the ratio from the balanced equation, and I did not have twice as much sodium oxide as carbon monoxide. Or you could actually sit and calculate it if you wanted to. Now that I know the limiting reactant, we can set up the stoichiometry. The product that we're looking for is the sodium metal. So we'll start with our limiting reactant. And we eventually want to get over to sodium metal formed. How much should we form? I'm going to use this 0.806 moles of sodium oxide. That's my limiting reactant. Always use the limiting reactant. And since I'm using it in moles right away, we can cancel moles of the sodium oxide and switch it over to moles of sodium metal. And again, I get it. It's a 2 to 2 ratio. So if you left this out, it's not going to change your final answer. But it just makes me so happy to see all my units line up and cancel. So now I'm in moles of sodium, and we can do one quick switch. We probably want to get this back to grams. Let's cancel grams of sodium. Or cancel moles. Hello. We're in moles. Moles. I want it in grams. Grams goes on the top. Periodic table tells me the mass of 1 mole. And it lists sodium as 22.99. And again, I'm not rounding that. I know there's a lot of people that are so tempted to say, oh gosh, that's so close to 23. But if your periodic table on the AP test says 22.99, leave it like that. We'll round at the end. Okay, cancel moles of sodium. And then we can plug this all in. We'll use 3 sig figs and say about 18.5. That's my theoretical yield. Theoretical yield. Excellent, because now I can do my percent yield. I'm supposed to collect about 18.5 grams of sodium. We actually got a little bit less, 17.8. Not bad. Better than the last one. Percent yield. The actual, which was given to me up in the problem, the 17.8 grams of sodium, divided by the theoretical, which is calculated. Grams of sodium times 100, which, I mean, this is kind of weird. If you want your final answer to be a percent, on the AP test, they do want you to say times 100. It seems like such a silly step, like, why can't I leave it out? But they do want you to leave that in there. They're looking for it. Okay, so what do we got here? If we go 3 significant figures, let's say a 96.2% yield. Not too shabby. I'd say that's pretty darn good. All right, so it's mostly a limiting reactant problem. And the last part is really all that's different when we finally calculate the percent yield. They give you the actual in the problem, and we'll just divide by the theoretical. Now, if we wanted to really review the whole shebang here, they might ask me something like this. And I mean, this whole thing would be like a multi-step free response kind of problem, which might be worth like up to 10 points, with points allotted for each individual step along the way. So if by chance you calculated the limiting reactant wrong, you're going to get the wrong theoretical yield. But if you calculated the theoretical yield correctly with the wrong limiting reactant, and then you did the percent yield correctly, you're not going to get like double jeopardy. They'll take off points for getting the wrong limiting reactant, but not on anything else. So your answer could be brutally wrong, and you may only lose like a point or two. That's the beauty of showing your work. So they can follow your steps to tell that you had this set up correctly. How many grams of the excess will be left over? All right, so this looks real similar to calculating that theoretical yield. We start with our limiting reactant. It determines not only the amount of product formed, but also the amount of the excess used, the limiting reactant. So these calculations look real similar. We'll cancel moles of sodium oxide. But this time we're going to switch it over to the excess, the carbon monoxide. This was a 1-to-2 ratio. Moles of sodium oxide out. And again, from here, if you want, you can leave it in moles, or you could switch it to grams. At some point, we need to get it into grams. So if you want, you can tack on one more. Cancel moles, put it in grams. I think we said 28.01 maybe was the molar mass of carbon monoxide. These guys are gone. So we could plug this in, leave about 3 sig figs. Maybe we'll say about 11.3 grams used or reacted. And then all we have to do is subtract it from the amount that we originally had in the problem. We had 19.2 grams originally. We have 19.2. We're only going to use 11.3. So the difference is the amount excess. We should have about 7.9 grams excess carbon monoxide. Cute. There. We're getting good at these, aren't we? And again, you could have done the subtraction in moles or grams as long as eventually you switch it back to grams. Now the last little part of this, it's kind of a cute spin. What if we run this reaction 100 times. And in industry, this is really what they'll do. They'll run a reaction hundreds and hundreds of times so that they can get kind of a typical percent yield. This reaction consistently runs at a 75.4% yield. So we must have just had a really good trial. How many grams of sodium would you actually collect? Okay, so taking into consideration that percent yield, this typically runs at a 75.4% yield. You typically lose about 25% of your product. So we calculated the theoretical yield before with those quantities, and we'll assume that we have the same quantities, the 50 grams of sodium oxide, the 19.2 grams of carbon monoxide. We were supposed to form 18.5 grams of sodium. That was the theoretical yield. But what if we actually don't collect all of that? What if we lose about 25% of it? You can set these up a couple different ways. I would probably take this out of a percentage right away and plug it in as 0.754. Actual over theoretical. We're looking for the actual. The theoretical was 18.5. We're just going to cross multiply and boom, we're done. Some people do this just, conceptually. It makes sense. You're supposed to collect 18.5, but what if you only get 75% of that? 75.4% of that. All we have to do is cross multiply. So we would actually expect about 13.9. I can make a better decimal spot. 13.9 grams. We would say like expected to collect. We're going to lose about 25% of it. So just another way of kind of manipulating this concept of percent yield. But conceptually, it makes total sense. So I don't have any worries that you'd be able to solve something like that.